We're left with number B.
Yeah.
2B and number 3. That's why I said tomorrow we are going to we'll do 2B and 3. We'll continue with it like that. Then I think we'll be left with 2 questions. There are 5, isn't
it? Today we're gonna do number 2A, number 2B, and then question number 3.
Yes.
Okay. No problem.
Is the screen sharing?
Yes.
All right. So yesterday, where we left, when we were showing that they have PowerPoints, and also when we show that delta omega, change in omega, is given by this. We showed it yesterday on that recording, how we were showing this delta omega, which is omega 1 minus omega 2, the delta.
Okay.
So we're showing that delta is equivalent to R over L. And we also showed that those W1 and W2 are half power points. How do you do that? First, I explained this on the previous recording, how we got that. The power points, which means that I, which is the power points, are given by that formula P, which is this I RMS, root mean square, which means multiplied by R. That is the definition of this one, of the power points. So we want to check that the power at W1 and the power at W2, it's half of the normal power. So we derived an equation for power, and then we found out that power, P max, is I naught squared R in general. This was the general equation. So that is was our equation. So in relation to W1 and W2, what were we doing? We said, what is the power point at W1 and W2? The power point at W1 and W2 is given by this formula, P, just P, not P max. So it's given by just P. So when we calculated the P, we found out that the P RMS, it just means the root mean square, whereby you say I naught, which was given on the question, divided by root of what? 2, and then you square, then multiplied by R. So when we squared and multiplied by R, we found out that the power at those points, it's I naught squared R divided by 2. That's where we concluded that if it's I squared R divided by 2, is the same as saying the P is equals to half of what? Of I naught squared multiplied by what? By R. Then what is that I naught squared multiplied by R is P max. So we came to the conclusion that P is equals to P max over what? Over 2. That way.
So the square root, or the square root is the one that we were given on the question, right?
Yes. For
the
those,
I naught over the square root of 2 we were given on the question.
This one, it was given.
Yes.
This one, it was given. So you were told that suppose W1 and W2, W1 and W2 are 2 values of omega on both sides of W naught, at which the value of I. So you were given that the current at W1 and W2, the value of I at W1 and W2 is equals to
so you replaced that. I'm sorry.
Yes.
You replaced that I on the formula with the
Yes,
I squared with the I naught over the square root of 2.
exactly. That's what
Okay.
that's what we. So after we simplify everything, that's when we found out that it's after squaring, you found out that P is equals to half I naught squared multiplied by R. But in general, P max is I squared multiplied by R. So I just replaced this term and then you put what? P max. That's all. That's what they wanted us to prove.
So when you're writing, you start by the P is equals to
Yes.
this, and then the P max, and then you show how you have derived the formula until you get this.
Until you see what is the similarity between this P and the P max, or what is the relationship. The relationship is that P is equals to half of P max. That's what we are just showing. So this P
Okay.
power is the power at points W1 and it's the same power at points W1.
Okay.
Get it? That's all. So that's how you're supposed to deal with this one. And this one was part A, isn't it?
Yeah, that was number A.
Then this one for showing that it was easy when there were values which were cancelling out. We calculated the omega, W, W2 and minus W1. But there's something which I just want to show you when they were calculating here, when they were replacing the values. So they solved quadratically. I indicated in the previous recording, we solved quadratically. But here, how did they change here to come to omega squared? How did they come? This is the point which I wanted to explain, this one. What happened from here to there? All of a sudden, I have WL, and what happened now? From WL.
Is it part of question number A?
Yes, yeah. When we were calculating, remember, we want to solve for show that W1 have power points. This one, when we are showing now for A, that W, change in W is W2 minus what? W1, which must give me a final answer of what?
R over L.
R over L. Can you see? So, which means, where are you going to start? With that one, we showed you where you are going to start. Where we were talking that voltage is equal to resistance times current. And now, in terms of resistance, we are using impedance Z. In terms of voltage, you are using E naught, which is your EMF. You get that one. And at the resonance, always you must know at resonance, your impedance is root of 2 multiplied by R. The same way when we are calculating RMS current is at the resonance. That's when we canceled everything. This was 0, 0, and then for example, our current RMS is equal to I naught over root of 2. So, like I explained yesterday, that at the resonance, Z is equal to R. So where there is Z, we are replacing this Z with what? With R.
Okay.
You get the logic? Yes, where there is Z, you replace Z with R.
So that's where we start when we are proving.
We are proving, yes, that's where obviously we are going to start. We are starting from the basic concept that voltage is equal to resistance times current, and then you make current subject to the formula. Current is equals to voltage over what? Resistance. That is
Yes.
the equation we are dealing with. Okay. Then, because we are given an inductor, capacitor, resistor circuit, LCR circuit, which means it has those components, which means we are replacing where there's V, now we replace the V with the E naught. The V is replaced by the EMF. The R by the impedance. That's what we did then. The R is replaced by the impedance, and your current, the same current. That's only, those are the only changes. This was the from matric level. This information, it's matric level, this one. Now this is varsity level.
Is this where you said yesterday that because what's that thing? Oh, I forgot the name.
Resonance.
No, the in metric level, the one that is always measured in volts.
Yes, EMF.
Yeah.
Yes, the EMF.
Yeah.
Which is E naught.
E naught. So that's why you replace the voltage by E naught.
E naught, which is the EMF, yes.
Oh,
because now the EMF electromotive force is it's now given as a function, this one, the EMF. So it's a function. So the EMF E naught sine omega t.
Oh, they even wrote the
Yes,
okay.
Yes. So what I just wanted to say here is starting from there. This is the introductory concept when you are solving it for the second part, which we are proving that, remember our aim was to say, show that change in omega is the same as omega 2
minus omega
1, which is the same as R over
L.
Over L. That's where we are going. So by starting this game, we are starting it here. Current in a circuit. You start by the definition of current in a what? In a circuit. That is your starting point here.
No, so these are just some of the formulas that we need to know. Because
yes.
you're not
Yes. So now we are coming, you write it, resonance, Z is equals to R. So where there is R, now you put your Z there, the denominator. So now instead of it being E naught, and where there is I, now we are putting I naught.
Oh, yeah.
So we are putting I naught. That's what you are doing.
So because it's saying when I, the current, is equals to where, I naught over square root of 2. Do we also write I naught square root of 2? Where there's I.
Where there's I, do you also write what?
The square root of 2. Because here, is when I equals to I naught
over root of 2. Yes, over square root of 2, yes. So your question now is saying what? Where there is I, do we write
I naught over square root of 2? Do we write it like that?
Or you mean there, where you are saying I naught over root of 2 is equals to
I.
Then that one is the E naught over R. Is that what you're saying? And then the R, we replace it by the what? The Z.
The Z. Oh, yeah, that's what I was saying. That's how we write it, right? Okay.
So from here, once you explain your concepts to say I naught is equals to E naught over R, which means you replace the Z. Z is equals to R at resonance. So your current, when, which means this is given, isn't it? When current is, when this is given, when your current is equals to I naught over root of 2. What does that mean? It it means Z, the impedance, which means now we are using, isn't it? We said Z is equals to R, isn't it? So
Yes.
Z is corresponding to I, because the formula that goes hand in hand with Z is I. But if we changed our I is now a root mean, which means our I is equals to I naught over root of 2. If you are going to use this I, also the Z here, it also changes, which means it's going to be root of what? Of 2.
Of 2R.
What is the, yes, what is the relationship between current and voltage?
And what?
The relationship between current and resistance.
I'll
Is
say
it
they're directly proportional.
Resistance and current, they are inverse. They are inversely what? Proportional.
The what? Resistant and
Current.
yeah,
Resistance.
the R and I is
They are
inversely.
yes.
And then the V and I, they're directly proportional.
Yes, they are directly proportional. So if you divide your I, if you divide this I, which means by root of what? Root of R, without changing the value of the what? Of the V, which means I'm not changing the value of the V. So which means this is my I is going to be I naught over root of what? Over root of 2. So which means my resistance must also be root of 2 multiplied by what? Root
R.
of 2 multiplied by R. So that those root of 2 can cancel out. Root of 2 multiplied by R. So that the value of the voltage remains constant. So if I decrease the I naught, the resistance is going to increase, but the voltage is going to remain the same. This will cancel with that. It's still R multiplied by I naught. Nothing has changed. So that's where this idea is coming from, that our resistance is going to be 2 root R. This is the 2 root R here, root of 2R, which is one root of 2R. It only happens if I make my I naught, my current, be I naught over root of 2. So the condition that were given on the question paper was I naught is the current is going to be this I is I naught over root of 2. So if my current is I naught over root of 2, then automatically my resistance will be also root 2 multiplied by R. Why root 2 multiplied by R? I must not change the value of this voltage. The value of the EMF does not change, of the EMF, it remains the same. That's why this will cancel with that. So definitely the root of 2 must multiply the R if we divide the I naught by root of 2. That is where this is coming, where it's coming from, this idea. That Z is equals to root of 2 multiplied by R. Since we said at resonance, Z is equals to R.
So what we are going to have after we have divided, it's we're gonna have I naught is equals to the EMF I naught over Z.
That is the starting point, isn't it?
Okay, I was just surprised where the I naught is coming from, because
the I naught, isn't it? It's from for given information.
Yeah, I understand now after you have explained.
Suppose which value, suppose with the value of, it's a condition that I is I naught over root of 2. Then where we are talking about at resonance, where I was explaining yesterday, after you put your values, then you say at resonance. At resonance, let me delete this. at resonance, Z is equals to R. It's coming from here. So you can copy the equation, copy this equation. You write that the impedance in a LCR circuit, okay, in an LCR circuit is given by this formula. Z is equals to root of R squared plus X, which means the resistance for the inductor for L, then the C is for the capacitor. So at resonance, which they are talking about here, that's where I was putting 0. At resonance, where is the Z equals to R coming from? It's coming from the idea that at resonance, XL is what? 0. XC is what? 0. That is at resonance. So which means your Z is going to be equals to root of what? R squared. So Z is equals to R. That's where this Z is equals to R is coming from. This one, which they
yeah.
coming from. That's where this Z, which is equals to R, is coming from. Can you see that one? At resonance, Z is equals to R. It's coming from the idea here that Z, this XL is 0, that one. Then Z is equals to R. Then the idea of saying Z is equals to root of 2R. Where is it coming from? From this idea which I explained here. If Z is equals to R. So which means if my current drops, if my EMF, which is E naught, EMF, voltage is equals to resistance, which is R multiplied by the current. So if my current is now I over I naught over root of 2, which means also my resistance must, by dividing by this number, which means we are increasing also the what? The resistance. So if you divide by a number, then you are dividing, which means this here is dropping, then the resistance must what? Increase. So you are also going to multiply by the same reduction, which is root of 2 multiplied by R. So that the value of EMF stays the same. So E naught is going to stay the same. Why? Because this and that will cancel. The same reduction on the current was the same increase on the resistance. So it was not having any effect. That's why the Z, which we are going to use here, is now root of 2R, which means our R is increased since we are now using I naught over root of 2. So when we are using from the question, we are using I naught. I is equals to I naught over root of 2. That is what we're told to use in our question. But if we were not told, we're going to use this one. Just Z is equals to R.
Okay.
That's the idea. So where is this coming from now? It's coming from the formula. Where there is Z, this formula, where there is Z, you replace that Z with the 2 root of R.
Yeah.
So Z is equals to square root
of R squared.
R squared, isn't it? Plus what?
Plus bracket
X,
XL
minus XC, everything
squared.
So then you must know the formula for XL, formula for XC, which is given by this. So these are the information which must be there. So we are now replacing here in the equation. Where there is Z, you put 2 what? R, isn't it?
Yeah.
Where they get this Z, now we are putting root of 2R. Where there's R squared, you leave it like that. Where there is XL, you are putting this value now. Where there is XL, omega L, XL, omega L. You put your omega L. That is your omega. Your omega L. Where there is XC, 1 over omega C squared. What do you do? Here, I told you we squared both sides. On the left-hand side, you square. On the right-hand side, what do? You square. Are we together? Are you following there?
I think I'm a bit lost.
Yes.
Okay,
Where are
you
you?
gave me the formula, ne? The Z equals to, and then you showed me the formulas for XL and XC. So can you please explain this, the last part, this one that you just explained now? I think
We are replacing the formulas where there was XC. Remember, this was Z.
Oh, you are replacing the.
We are replacing. Where there is Z, you are putting this 2R. This one. Where there is R squared. Here, remember, there was X what? See, this was, XL. This was
XL, yes.
and X
Oh,
what?
from
C.
XC. Oh,
Replace
now I follow.
with these values here. These ones, you are replacing with these values.
Yes.
That's what we did then. After you have replaced, you square both sides.
Yeah.
Now you both sides, which means you square the left-hand side, you square the right-hand side. So here, you are going to come, it's a square root, you square. This side, it's a square root, you square. That's why you are going to say the root of 2 squared is 2. R squared, that's R squared.
R squared.
This side, right-hand side, only the square root goes
out.
But everything under the square root stays. That's your mathematics. Then from there, you group the like terms together, which means the R goes to the left. So in other words, it's 2R squared.
Minus 1R.
R squared.
Left with R.
So you're left with what? With R.
R squared.
The right-hand side remains like that, which means this is just your right-hand side. Then from there, you find the square root. Isn't it? You want to remove the square.
Yes.
Yes. So R will be equals to what? Which means
squared is gonna be R squared will be R, and then the other side will also remain the same because you're removing the square.
Yes. So which means, in other words, we have squared both sides. So in other words, we're supposed to put a what? A bracket here.
Bracket.
But we did not put a bracket to say R is just WL over 1 over WC, but we are removing the square now. Those lines are absolute. Why are we getting absolute values? Why are we getting absolute values? This one. They are getting absolute values. Why? Can never be what? 0. It's not going to be 0 here. And I will show
the absolute value, it means that the answer will never be 0.
Not be 0. For example, after we are done, we get our R. Here, we just, they just put the R now, they just put it on the right-hand side. So in other words, the R can never be 0. That is the absolute. It can never be a negative. An absolute, it means if it's a negative number, then the actual absolute of -1 is equals to what? 1. Absolute of +1 is equals to what? Is equals to 1. In other words, they are saying resistance can never be negative. You can't say, what was the resistance of the circuit? The resistance was -5 ohms. No.
Yeah, I remember that from physics. Yeah, it can never be negative. Yeah.
Resistance can never be negative. That is what is happening here. Resistance cannot be negative. So that's why they put the absolute. That if you are going to get an answer for R that is going to give you a negative, then use the absolute of that answer. For example, let's say you are calculating and you got your R is equals to negative 1 ohms. So you put an absolute, then the answer will be what? 1
ohms.
That's what this means. So here you are not going to put brackets. You are going to put R is the absolute.
So there's a possibility that you can get a negative, because I know in physics you can never get a negative.
There's a possibility that you, when you are calculating, are going to get a negative. So this is trying to protect you to say, even if you get a negative or a positive, but the final answer going to put, the answer that we are going to take is only the one. The positive
I was
values.
gonna be very shocked if I found the negative. I was gonna rechange everything, because from high school to college, the resistance, you can never get a negative number.
No, you cannot get a negative number. So that's where it's coming from here. So after a year, then you are done. So which means if you don't want to put that absolute, can you see that they said R is this, isn't it? So now can you see that how did they reverse? They did not put the absolute this side. So which means what are you going to get? It will be plus or minus the R that you get. That's what it means. So in other words, if I get negative 1, I'm going to say the answer, it will be minus bracket minus 1 ohm. If you are going to get a negative answer. If you are going to get a positive answer, it will be positive, the answer. So it's being replaced. The statement you are just replacing by this.
Yeah.
That's all.
I think the hardest part is knowing the formula. Because
So you have taken out the absolute, you must introduce plus or minus R. That's what they just did on that step.
Okay.
Let's introduce plus or minus R. So if you don't want to put plus or minus R on resistance, then you are going to write it like this. Can you see? With an absolute. So that when you get an answer which is negative, you know. Here, if you get an answer which is negative, which means we are going to say, I got minus 1 ohm, and my R was equals to negative what? R, isn't it? So what is the value of R, which means you are going to divide by that negative, which you got negative. Then at the end, you find R is going to be equals to a positive one answer. That's what they are doing. If you got a minus 7, which means you're going to divide by negative 7, negative 7, negative and negative, cancel, negative, negative, cancel. Then at the end, you get your answer in positive. That's all. So that is the step here. Once you have found your value of R, what are we going to do with that R, which we have found? That's the R which is going to assist us. Remember, we are here now. We are at this step. Can you see this step?
Yes.
That's where we have introduced the R, which is not in the absolute form. Then, what did you do here? You multiplied each term by omega. You want to come to quadratic equation so that you can solve for W1 and what? W2. 1 and W2. So which means, how do you know W1 and W2? Because a quadratic has 2 solutions, which means this is solution number 1. 1. This is solution number 1. Number 2. You get what you are saying?
Oh, you multiplied everything by omega.
By omega. So that we are going, at the end, we are going to have 2 values for omega. Because if it's a quadratic equation, if you have x squared, which means at the end your solution will be the first x1 and then is equals to something, and your next solution or x2 is equals to something. Always you are having two values of what? Of x.
X, Y, and
Yes.
X.
Yes. But in metric, we just say x is equals to or x is equals to. But now it's physics, they are now being specific. X1 is equals to what? Or another x2 is equals to what? That's all. So here you are just using the same concept of quadratic equation. So from this step, you are going to multiply each term by omega. R times omega, this times omega, this one times what? Omega. What is omega times omega? Omega what?
Omega squared L.
Multiplied by what? L. And then we go to the next term. Omega cancels with omega. What are you left with?
1
minus
over
minus 1 over c, which is this term.
yes.
And plus or minus. Remember, plus or minus is compensating the absolute. Compensating those absolutes, okay?
Yes.
Then plus or minus r multiplied by omega, what do you get?
RW.
RW, which is this one.
So when you change the
So
position of RW, also
yes,
the sign changes.
Yes, isn't it? It was plus minus.
Yes.
It was plus minus r on the right, isn't it?
Yes.
Yes. So here, when it comes this side, the plus becomes the what? The minus. Then the minus, which is on the bottom, becomes the what?
The plus.
Yes. So if on the right you had written a minus plus, when it comes to the left, which means you are going to write plus what? Or minus. That's all. You get it? Because we are saying this is moved to the left. So instead of saying plus or minus, I'm also indicating that it's minus and what? And plus.
Okay.
Get the logic. Any question then?
No, I'm clear.
All right. So here we multiply by omega. So don't forget that step. We multiply by omega each term, omega each term. And then that's what we do. Now you use quadratic formula to solve. Isn't it? Now it's a quadratic form. We are having x squared, then the constant plus or minus r omega, and this is just a constant. So use the same concept when you are solving for quadratic. X, isn't we say x is equals to
Plus or minus B.
plus or minus what? B. Isn't it? Yes, plus
Square
or minus.
root.
So here, according to this standard equation, this is your A. Sorry, this is not your A. Your A. This is your A. This is your x squared. Then plus. This is your B, x. And then plus C. This is this one is your constant C. So that's what we are using here. So x is equal to minus B. What does it say? Minus B.
Plus or minus B.
It's not plus or minus. X is equals to minus B, not plus or minus.
Oh, yes. And then
X is equals to
B.
plus or minus. So x, let's solve it. X is equals to, delete this one. That's problem. Right. So our x, so after we've identified our A, B, so we are here. We said this is x squared, and this is the coefficient A. And this was minus plus. R is the B, x plus C. C, which means it's negative. Negative 1 over So this whole negative 1 over c is your constant as a whole. Not only c, but the whole term here. This is your c plus c. That's what we need. So how do you relate this to quadratic? The formula says your x is equals to minus b plus or minus square root of what?
B squared minus 4ac over 2a.
Over what?
2a.
2a. So, which is the same as saying minus b. In our question there, what was b? B was minus. Yes, but b is minus plus. So you reverse the order. Remember the order is minus bracket minus plus. Can you see? So it becomes plus or minus. So negative times negative is a what? Positive.
It's a positive.
The negative times positive is what?
It's negative.
B is equivalent to R. Your x is the omega. The x is the omega. So which means you are going to get two roots. Then you name those roots root 1, root 2. Then at the middle term, it does not change, isn't it? It's just plus or minus square root of 1. B squared, we said B is R.
R squared.
R squared, which is this one.
Yes.
Minus. So here, we're having minus. So it will be R squared minus 4 AC. Our A is L. C
negative 1 over C.
So you can see negative, negative, give you what? Positive. So it will be positive 4L over what? Over C. Which we are
over C, yeah. 4L over C.
Over C. Then divided by what? 2A. A is L. So divided by 2 what? L. Can you see? Since omega must be positive, omega has to be positive. So which means we are not going to have an R that is going to have a negative. Omega must be positive. So which means we are not going to have R that is going to have a negative. So where are we going to disregard the R? If omega is going to be positive here, we are only going to take only a positive side here. That is the only difference. So which means there, we don't want any value for what? For positive, negative. For both of them here must be plus. There also it must be what? Plus. Only after the R, this one. Instead of saying plus or minus, you remove the minus. Since we want omega to be what? Positive.
Positive.
Because you can't have a negative omega. So since omega must be positive, then, which means here, we are not longer going to put a minus here. We are only going to put a positive. That's what they mean there. So which means our two values, they are coming from the idea of W1, it will be this one, the first one, positive and negative. This is the negative, and then this is the positive. But this does not make omega to be what?
To be negative.
Negative. It does not make omega, because this, what is on the right-hand side, it's already big. Here I have R, and already I have R squared. So which means there's no way it's going to be
a negative.
Yeah, a negative. So from here, you are done. You have your W1 and W1. 2. Can you see how we got W1 and W2? These are the roots of the equation. And the question was, calculate the change in what?
in W omega 2
No,
minus omega 1, which is supposed to
which
give
is
us
the
R
same
of
as omega 2 minus omega 1.
yes.
So which means now we are subtracting those two. You must show that this is the same as R over what?
Over
Over
N.
N. Yes, that's what we are doing now. So let's add them together, W2 and W1. So it's a matter of fractions. Let's start with W2. It's W, change in W, change in omega, is that frequency. R, it's R over 2L as a fraction, because there's 2 what here, L. Can you see it?
Yes.
So it's W2, which we are starting with. Then we say plus the square, everything that is under the square root there. It's R squared plus over C. Everything there under the same common denominator, which is 2L. We are done with the first part of W2, which means we are looking for the change in what? In W, which is that. But the question is saying minus, so we put a minus. We are subtracting W1. What is W1?
W1 is negative R.
Yes,
plus,
so we are going to put minus bracket negative R over what?
over 2L,
2L
and then plus
plus,
square 2 minus 4L over C all over 2L.
exactly. So it will be plus the same thing, square root of R squared plus 4L, which means over C, everything over 2L, over 2L. So negative, negative. Now we want to solve now. We are going to get that W, which is this change in W. We have this R over 2L. So it's R over what? 2L. So negative times this negative give you what?
A positive.
Positive, which is R over what? 2L. This is a positive, and this is a negative. Negative times this positive give you a negative. Which means these two, they are going to cancel out to be minus. So it will be the end, you are just adding plus 0 of those things. They are canceling. So which means you are left with change in omega is equals to R plus R to R. But the denominator, you don't add to say 2L, 2L. These are fractions. They have the same common denominator. It's just like half plus half.
Yeah, it's 1,
It's
not
1.
2 over 4.
Yes. So you do the same. Here it will be over 2 what? L. Then also 2 and 2 are cancelling.
And then we have R. Yeah.
Equal to R over L. Then they cancel. Then we are
I
done.
was not gonna get this on my own, shame. Yeah.
That is W over N. So we are done with the B part. Then let's finish the last one. So we're repeating the B part, but let's start with the.
Which one is that question?
This one was for A. B, we have not touched B. Neither have we touched number C. So
we're still on to number A, right?
yes, we are clarifying number A. However, all the answers are there. All the answers are there. So we wanted to solve the B part. So the B part is saying
the quality factor of the circuit.
Yes, the quality factor of the circuit is given by Q is equals to W naught over W naught multiplied by L over R. So in other words, they are just saying Q is equals to W naught multiplied by L over R, the multiplication. Or if you want to put a line, to be something like this. That's what they just want to multiplied by that. So this one was the proving for question number 3. So the one which we want for L over R, this one. So I will share with you, but it's not a difficult one. So show that W1 and W2 are half power. With this one we did it, isn't it, for half power ones? And then this one, this is the one which you have done. So this part is number A. So this one was part number what? Number B.
Oh, that's question B.
Yes. So what's given in the question, we know what is given. This information was given for I naught and W1 and W2, the angular frequencies, omega 1, omega 2, which is the angular frequency at that point, at this current, which was given. So we calculated them. And this W naught, which they are referring to, is what we call the resonance angular what? Frequency at the resonance. Remember that time when you said Z at the resonance is equals to R? Yes. So
Number B. Are we're gonna start with it tomorrow?
For number what?
Number question 2B.
I will, or your brother, that will be a challenge.
Yeah.
All right, it's fine. But at least you have clarified. I've clarified number 2A. Easy for you to write, isn't it?
Yeah, so we're done with question 1, question. So I'll start writing those and then here.
Then we have a session for B and D. So tomorrow I'll start again. I'll start just from B and 3 so that we can finish.
We can finish, yes.
But there are not many questions. It's only 5 questions. We are almost done.
Yeah, we're almost done because it's closing on the 19th of May.
No, there's time, I know. Yes. But at least we have understood. That is what matters. Okay. Let me attend your brother now.
Okay. Bye.